Okay, this video is going to look at the coordinate systems we typically use in astronomy. So we need to start off with some definitions. So from the observer's viewpoint, the point directly above the observer is called the zenith, and there's an imaginary line that goes directly from the point from the north horizon all the way up through the zenith to the southernmost point of the horizon. This is called the meridian line. So the sun, stars, planets, we say they rise from the east. It's just due to the Earth's rotation, of course, but the appearance is that all these planets, suns, etc. rise from the east, passed over the meridian line and set in the west. So the highest point they reach is when they cross that meridian line. So there's two words we use every day. It's AM, which is ante meridiem, meaning before the sun has reached the meridian line, and PM, post meridiem, which is the afternoon when the sun is setting in the west, having gone past the meridian line. The other point that's marked on this diagram is the nadir. So the nadir is the point directly below the observer, and of course that would pass through the Earth's centre off to a point at infinity directly below the observer. So remembering that the Earth is tilted on its axis, now this is in respect to the how the solar system moves. So the solar system pretty much revolves around the sun and is like a big disk, so it all fits pretty much on the same plane. There are a few that go off that plane just a few degrees, but pretty much the solar system is a plane. Now, given that the Earth is tilted at our 23.5 degrees, that means that depending where we are on the planet, we're going to get a different view of how the stars and the solar system appear from the Earth. If we're at the North Pole, for example, so this is the first diagram, and we looked upwards, we would see all of the stars just rotating around us. So if you can imagine you're at the North Pole, we'll just jump back and have a look. So at the North Pole here, the Earth is rotating around, spinning on its axis. All the stars would appear to just revolve around the sky as shown in this diagram. If you're at the equator, all of the stars, planets and the sun would rise in the east, just go straight up, straight down, setting in the west. If you're in the northern hemisphere and you looked up, things would be a little bit tilted. So this is an example. If you're at a latitude of 40 degrees north, you would look up. In the northern hemisphere, there's actually a star right in the middle of that point called the North Star, and all of the other stars would rotate around that point in an anti-clockwise direction. Down here in Melbourne, which is roughly a latitude of 40 degrees south, we look up. There's actually no star in the centre of this circle. All the stars would appear to revolve around or rotate around what we call the south celestial pole in a clockwise direction. This can be seen from this photo. It's a time-lapse photo taken at the Anglo-Australian Observatory. So if you measured the height from the horizon up to that point in the centre of the star trails, you'd be able to work out what latitude you were at. So the photo has been taken and allowed the stars to move around, leaving these beautiful star trails. So how do we measure where a star is? So the simplest system to describe is called the alt-azimuth system, and from an observer, so we've got the zenith directly above them, hopefully we know where north is, and we see a star. We locate that star by saying what its altitude is, how many degrees above the horizon it is, and the azimuth, which is how many degrees around from north. Now a simple way of measuring that is shown in this diagram. If you outstretch your arm and then outstretch your hand, the angle between your little finger and your thumb is roughly 20 degrees. Now I'll tell you how we can get that and how you can measure and check that it's 20 degrees for you. If you look out, go outside, find a point on the horizon and line up that point. Let's say it's a house or a tree. Line it up with your little finger and find something that is lining up with your thumb. Now move your hand across so your little finger is now with this new object, and that would be one hand span that you've just moved. Go all the way around the horizon and measure how many hand spans it takes to get around the horizon. For most people that's around 18, so for 360 degrees divided by 18 hand spans means that each hand span is roughly 20 degrees. This can be quite useful. If we go back to this diagram here, we saw this star at this point. If we said that's 2.5 spans up, we could say, well, the altitude is 45 degrees, and if it was 2.5 hand spans from north, then the azimuth would be 45 degrees. If you want to take this a little bit further, if you hold your fist out, arm stretched, your fist is about half the size of your hand span, so that gives you a angle of about 10 degrees, distance between the knuckles about 2 degrees, and the width of your thumb about 1 degree. So some people can use this to give surprisingly accurate measurements. So that is the alt-azimuth coordinate system.